lesson 33 homework problems. There's only 4 problems that we didn't get to. So let me do those quickly. The first one, number 17, when you do these, when you look at the problem 17, it has a whole bunch of writing. When you see that, just go to the very end. It says make a sketch of the graph of the reciprocal function. So you can just skip, when you're doing that, just skip down to where it says make the graph of the reciprocal function. So it's going to be g of x equals 1 over. These should be some of the easier problems that we do once you understand how to do them, of course. X minus 2 quantity squared. Okay, now, first thing you want to do, we don't talk about this very much, is find the domain of the function. Now that's a bad word for you guys, domain. I know you always hate those kind of problems, but we're going to find out what x cannot be. So let's look at this. There's no radical, so we don't have to worry about anything being greater than 0, but we know that the denominator cannot be equal to 0. This cannot equal 0. So we're going to determine what would make it equal to 0. There's only one thing that would make it equal to 0. It's if x would equal 2. So we're basically going to say x cannot equal 2. That means your graph in no way can hit the vertical line, which is the graph of x equals 2. So I'm going to put in, when you find what it cannot be, we're going to make an asymptote, which is a line that the graph will always approach but never touch. So we're going to get x cannot equal 2. So I'm going to make a dotted line down x equals 2. Or as close as I can get it. That means the graph cannot cross this line, it can't touch this line, it can never, x can never equal 2. So once we get that out of the way, always do that first and figure out what your asymptotes. Another thing, if you look at this, you'll notice that there's no value of x that we could ever put in here to make this fraction equal to 0. So the other asymptote, which we can't really put in, but I'm going to try here, is y cannot equal 0. Because there's no way we're going to get a y value of 0. There's no way to make this equal to 0. There's no value of x that would do that because we don't have a variable in the numerator. There's no way the fraction can equal 0. So keep that in mind. So what we basically did was divided our graph into 4 new quadrants. So we're going to pick points. You probably want to pick 4 points for this one. I'm going to pick 2 on this side of the asymptote, and I'm going to pick 2 points on this side of the asymptote. And then I'm going to erase these so they're not in our way. So let's just start out. 0 is always a good point to put in, a good number for x. If we put 0 in, we're going to get 1/4. Let's pick a couple other ones. If I put in a -1, we're going to get -3 squared is 9, so it's going to be 1/9. Now, are you noticing that there's no way we're going to be able to get a negative number? Because when we square any negative number, it's going to become positive. So basically, we're not going to have any graph in these bottom coordinates where y would be less than, would be negative. I'm going to put in a 1. And when we put in a 1, we're going to get 1 minus 2 is -1 squared, which would just give us 1. Okay, so far all the points I picked actually were on this side. So let's go over on this side. 2. If we put a 2 in, we're going to get, whoops, 2 doesn't work. Duh. Okay, let's move on to 3. If we put a 3 in, we're also going to get 1, and if we put a 4 in, we're going to get 4 minus 2 is 2, squared is 4, so another 1/4. So you can see it's going to be symmetrical. If we put a 5 in here, 5 minus 2 is 3, squared is going to give us another 1/9. So let's just plot those points and see what we get. So we get 0, 1/4. I can't quite, I didn't make my spaces very big. -1, 1/9. So it's going to start approaching the orange dotted line, but it's never going to hit it. If I put a 1 in, I'm going to get 1. And the same thing is going to happen. This side of the graph is going to look like this. It's always going to be approaching that orange line but never hitting it. I probably hit it, but and it's always going to approach this asymptote, but it's never going to hit it. Let's go on the other side. So we're going to get 3 is going to be 1. 4 is going to be 1/4, and 5 is going to be 1/8. And so you can see it's going to be the same thing, never going to hit this asymptote, never going to hit 0. So it's all plotting points and then just thinking a little bit about what it needs to look like. So these take a little bit of practice, but it's really just arithmetic, picking points and then graphing them. All right, 19. What is 19? Okay, little trig. F of x equals the cosine of x. G of x equals the tangent of x. We're supposed to find f of negative 180 minus square root of 2 g of negative 60. Now just think of functions are substitution problems. So this one says go to the f function. Here's the f function. Replace the x with negative 180. So you're going to get cosine of negative 180. That took care of that one. Now we're going to subtract from it root 2, and we're going to replace the x in the g function with negative 60. So we're going to get tangent of negative 60. Now, if you have 0, 90, 180, and 270, these are all called quadrantal angles. Quadrantal angles. I think that's how you spell it. Angles. Now these you can figure out by, I'm going to show you on the 180. I'm going to do my axes. And let's talk about, we'll do a 1 unit radius. So we have a point here. This would be 0 degrees. And the coordinates of this would be 1, 0. This one would be 270 degrees. The coordinates would be 0, 1. This one is 180 degrees. Track it along. 90 degrees, 180 degrees. The coordinates of this one is negative 1, 0. And at 270, it's negative 0, negative 1. Now cosine and sine are really easy. If we want to find the cosine of negative 180, let's just take it, we're going to go negative. It's the same thing as positive 180s. The cosine, the x-coordinate is your cosine, your y-coordinate is your sine. So we're saying the cosine of 180 is just going to be the first number in the ordered pair, so that would be negative 1. Everyone tracking with that? So if I said, what is the sine of 90, you would take this number. That would be the sine of 90. Okay, let's go on to the next one. Minus square root of 2, and we're going to do the tangent of negative 60. So we do our little graph, and we do negative 60, which would be down here, right? 60 degrees. Do the sides. So we have 1, 2, square root of 3. We're doing tangent, which is opposite over adjacent, so it's the square root of 3. It's going to be negative because it's down, it's negative, we're going down on the y-axis, so it's going to be negative square root of 3. So your final answer is going to be negative 1 plus root 6. All right, next. Next one is number 25. This one might not take all night to do or watch. Okay. Oh, this is just a messy guy. Hopefully I can get this right the first time. 2d over f 4s over g plus 2s over r. All right, so we have to find G. So G is very trapped, and you can see it as a mission to get G out. So the directions on this one say solve for G. So here's our G, we have to get it free. So first thing I'm going to do is distribute, so you get H equals 2ds over FG. Keep distributing, so we're going to get 4ds this time. And this should have been 8. Let's just start this over. Don't forget to multiply the numbers together. 8ds over FG plus 4ds over FR. Now, once you distribute, you want to clear it of fractions. So I'm going to multiply everybody by FGR. So let's just make this a little bit more exciting. So everybody by FGR, this guy by FGR, and this one times FGR. Or you can make one set of parentheses and put FGR outside of the parentheses. Okay, so we're going to get HFGR. The FG's cancel out, so we get 8DRS. The FR's cancel out, so we get plus 4DSG. Okay, hopefully we're good so far. Now, we're trying to solve for G, so we have a G here and a G here. We need to get them on the same side, so we get HFGR minus 4DSG equals 8DRS. Next step is you're going to factor out the G, so you get HFG, R, factor that G out, minus 4DS equals 8DRS. And the last step is we just divide both sides by HFR minus 4DS. HFR minus 4DS. And I should check to see if I got that right. Hold on a second. HFR 4DS. Yes. Okay. So this is your G, this is what G equals, and that's your final answer. All right. Believe it or not, we are on our last problem. 27. Oh, a proof. Yay. All right. So we need a rectangle. I like my rectangle drawer here. And we need to put some lines in it. So let's get some lines. We got that line, and we have this line. And here we go. All right, let's put our letters on. QTH, QTH, PS. All right, let's make our... These are pretty simple proofs. I don't think they give you much information like in the lessons how to do these, but we'll figure them out. We have statements. That's why we did geometry last year for those that were in it. And reasons. First thing is we are given that PQRS is a rectangle. And we're also given that T is the midpoint of QH, and these are given. Now it's all fun. What we're trying to prove is that triangle PQT is congruent to triangle SRT. We do this by, we can either say the triangles are congruent by side, 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 angle, side, whoops, that was bad, side, angle, side, angle, side, angle, side, and I think that's the last one. Those three, and you can also do hypotenuse leg. So if you have hypotenuse of one triangle, right triangle congruent to the hypotenuse and leg of another right triangle, the triangles are congruent. So I'm going to try to go through this fairly quickly, and I have a little room. All right, so first thing we can do, let's mark up our diagram. Well, let's just go. So if T is the midpoint of QH, we can say QT is congruent to TH. QT is congruent to TH. And you can just say definition of midpoint. because a midpoint divides a line segment into 2 equal parts. All right, we have 1 part. We have to get 3 parts. I can say QP is congruent to HS. And why can we say that? We can say that because these should really have segment lines over there when they're congruent. We can say that because opposite sides of a rectangle are congruent. So we can say the side's congruent to this side. And then finally we can say angle Q, well not finally, and angle H are right angles. And rectangles have 4 right angles. So we can say that this is congruent to this. And finally, nope, not yet, no finally yet. We can say angle Q is congruent to angle H because right angles are congruent. And now we're down to the finally. Finally, triangle PQT is congruent to triangle SRT, and the reason is side angle side. And that's it for this lesson and for this proof.